Hi everyone, Mechanics of Materials, Chapter 9, Stress Transformation, Planar Stresses. Consider a situation like we have a very thin a square plate, like for example from aluminum, having a two direction stresses, sigma y and sigma x. We want to see how to calculate the sigma and also their relevant strain as well. So we do remember that in Hooke's law, sigma is equal to E times epsilon. At the same time, we do remember that the collaboration of these people like Thomas Young, Simon Dennis Poisson, and Robert Hooke lead to a relation between, let's see, what is the relation between E and nu, like the work of Robert Hooke and also Simon Poisson, Dennis Poisson. So we do remember that in Hooke's law, sigma is equal to E times epsilon. And if you rearrange it like epsilon, it just a strain is a stress over modulus of elasticity. And base of Poisson ratio, nu is equal to minus strain in lateral direction over longitudinal strain. And that's nu. And at the same time, this is the original setup of a tensile stress, and this is elongated sample. And so if we are having a 1D stress, like for example, we have only sigma x, we can easily go by Hooke's law, and that says a strain in x direction is sigma. Sigma is E times epsilon. And if you just rewrite it based off epsilon, it's just this equation. And for also 1D stress in y direction, it's again like only applying y, and you can easily epsilon y is equal to sigma y over E. And now let's see what happens if we have both sigma x and sigma y. We call it planar stress, and it says a 2D stresses condition, and a combination of Robert Hooke and Simon Dennis Poisson comes to play. Epsilon is no longer just sigma x over E, but we do have also sigma y, which affects or a has a limiting effect on epsilon x. So let's see, either epsilon x is 1 over E sigma x minus nu Poisson's ratio times sigma in the other direction. So epsilon x is 1 over E sigma in that direction minus nu in the other direction. Likewise for y, it's the same. Sigma y is 1 over E sigma y minus nu times sigma x. So epsilon x is 1 over E and epsilon y is 1 over E sigma y minus nu sigma x minus nu sigma y. And if you just rearrange this equation, this time just based off sigma x, it just gives you a new equation. It just says sigma x is equal to E times epsilon x plus nu times sigma y. And if you do the same for sigma y and then replace sigma y from the second equation in the first one. So if you replace sigma y from the second equation in the first one, you will reach to this equation. Sigma x is equal to E times epsilon x plus nu times this expression, nu times E epsilon y plus nu times sigma x. And if you expand it and take all the sigma x in one side, it just and factor it out, it just sigma x times 1 minus nu s squared is equal to E times epsilon x plus nu epsilon y. So if that's sigma x and you just want to jot it down based off sigma x only, you can have it like sigma x is modulus of elasticity over 1 minus nu s squared over times epsilon x plus a new epsilon y. Likewise, sigma y should be again e over 1 minus nu squared, this time epsilon y plus nu epsilon x. And by planar stress, we do mean there is no sigma in z direction. That's why we call it planar. It's 2D, sigma x and only sigma y. If sigma z is equal to 0, then we can write down epsilon z is 1 over e sigma z minus nu times parenthesis sigma x plus sigma y, both of them. So if that's the case, and also in planar stress sigma z is equal to 0, and it just says, and by replacing sigma x in its equation and sigma y, replace it from here in the main equation, it just says epsilon z is 1 over e uh, negative nu times, replace this is sigma x and this is sigma y. And if you expand the equation and reorganize it, it just says you can cancel out this e by this one, and you can take the constant out that says epsilon z is a negative nu over 1 minus nu squared times factor out epsilon x in both equation, that's 1 plus nu. Do the same for epsilon y, is again epsilon y plus 1 plus nu directly from the top. And if you do so, it just gives you epsilon z is a negative nu over 1 minus nu squared times 1 plus nu times epsilon x plus epsilon y. And if you expand the denominator, it just says this is equal to 1 minus nu plus 1 plus nu times 1 plus nu. And if you cancel these two out, it just gives you a parametric value for epsilon z, which is minus nu over 1 minus nu times epsilon x plus epsilon y. If that's the case, sigma x, we already have it, sigma y, we already have it, and epsilon z is equal to this numeric value. We'll solve some problem on that. Thank you. Have a good day.